Yesterday when we looked at these equations, our main strategy that we talked about, wow, strategy, that's a tragedy. The main strategy we looked at was getting the base the same on both sides. So we had our powers chart, and if we could get the bases the same, so if this side is 2 to the something, and this side is 2 to the something else, then this something equals that something. Does that make sense? If you can get those bases the same, if both sides are 2 to the something and 2 to the something else, well, then those somethings have to be the same, and then you could solve it. And usually it's just a regular solving question after that. So the same thing's going to happen here. On this side, we have 2 to the x. So we want to look at the other side and figure out how can we write the other side as powers of 2. What can you change 8 to? 2 cubed. What can you change the cube root of 2 to? 2 to the 1/3. And now we have to go back to all of our power laws from grade 9. What do you do when you have the same bases and you're multiplying? Add the exponents. And when adding the exponents, are you okay if I change the 3 right away to 9 over 3? Why am I doing that? Because I'm adding fractions. I need a common denominator. And so I get 2 to the x equals 2 to the 10 over 3. So we're done step 1. We got the bases the same. Okay. So up till now, and continuing for a little bit longer, we're going to say because of logic, right, 2 to the x equals 2 to the 10/3. Because of logic, we can write, so we know that x has to be 10/3. Because we don't have any way yet to undo an exponent. Okay? We have mathematically, right, if you had this, how do you undo the square root? Square both sides, right? You have something to undo a square root. When you have this, up till now so far, you're just screwed. Nothing you can do. We don't have anything to undo the 2 to the x. And 7 you can't write as a power of 2 because it's not in your powers chart. So you could guess and check. I think it's going to be 2.8. No, not big enough. Try 2.9. Okay, a little bit closer. Try 2.91, 2.92, till you get closer and closer and closer. Okay? Right? We're going to find out later that we get to use something to get rid of bases. Any guesses what that might be? What's this unit called? Logarithms. Right? Technically, you could take the log base 2 of both sides there to get rid of the 2's. But we don't know how to do that yet. So for now, we're just getting the bases the same. Part B, here, I'll just send that to a new page. What? What? Where did it go? What did it just it just did something crazy. The whole file, there it is. Clipboard failed, who cares? All right. 125, 2x plus 1, cube root of 625. Are those numbers on the same column of your powers chart? Probably. They're both powers. So we can change this to 5 to the 3. And we can change this to 5 to the 4. I want to get both sides as a base of 5. I've got some extra stuff here. What do I do with the square root? It's 1/2. Are you okay if I do, should I do it? I'll do it like this. It's to the 1/2. What do you do? Whew. And this is 5 to the 4 to the 1/3. And if you could have gone to this right away, that would have been fine. And this right away, that would have been fine. What do you do when you have a power to a power? You multiply them. And what do we have another power to a power? We're going to multiply them again. And that 3/2 will get distributed, so we'll get 3x plus 3/2 and 5 to the 4/3 there. And so we've succeeded in getting both sides as a base of 5. Here's the something else. Yes?
I feel like this doesn't apply to like working because like you make the bases the same. But like for powers, like if you were multiplying stuff without the same base, what happens to the exponents?
So the question is, the only thing you could do in this situation is multiply this out to make it 16, and this to make it 9, and multiply 9 times 16. Okay? There is, can you see, you could undo an exponent law, sort of work backwards. Because the exponent law says when you have an exponent to two things, multiplying that exponent can go to both. So if the exponents are the same, I could write it like this and say it's the same as that. But that's only if the exponents are the same. If the bases are different and the exponents are different, there's not much that you can do. There's no exponent laws for those situations. Now that we've got our bases the same, we can go, so this 3x plus 3/2 has to equal 4/3. And we just want to solve for x. How do we subtract fractions? And x is equal to -1/18. All right, try some questions 9 and 10.